Hello and good day, sir. My name is Lim Jia Jie, matrix number 882000522. This video is about shielded metal arc welding. So as an opening of this video, I would like to talk about what exactly it is. Shielded metal arc welding is one of the type of arc welding. Its working principle is to melt the consumable electrode and form a bond with the base metal. The heat that is used to melt the electrode is produced by an electric strike between the electrode and the workpiece. The flux coated on the electrode will provide a shield to the weld pool to prevent it from oxidizing. Next, let's talk about safety. I will separate this part into before welding and during welding. Safety before welding. First, obviously, you need to know your equipment. Do not start the welding process before you are fully familiar with the equipment that is used for the welding process. Second, you need to evaluate your equipment because over time, your equipment might age and spoil. When this happens, the chances of an accident rise exponentially. Third, check your working area. Make sure there is no flammable materials. Fourth, consider the material you will be welding to identify the suitable electrode and electric polarity to use. Lastly, have an emergency precaution in place, for example, first aid kit and fire extinguisher. Safety during welding. First, wear proper safety gear according to this picture. Second, never look at a flash and always use your helmet. Third, use a helmet and head position to minimize fume inhalation. Fourth, avoid coiling the electrode cable around your body. Fifth, position the welder cable so that the sparks and molten metal will not fall on them. Now, let's talk about the procedure for shielded metal arc welding. First, as I just mentioned, wear protective clothes for safety purpose. The example for protective clothes can be referred to this picture. Second, clean the metal plate thoroughly to remove dust, dirt, grease, oil, etc. Then, switch on the power supply that is connected to the welding machine. Clamp the ground clamp on the metal table or the metal plate. Step number 5. Connect the electrode holder and the ground clamp to the terminal of the welding machine. Then set the suitable current and electric polarity. Next, place the metal plate on the table and adjust it to comfort. Make sure the metal plate is flat to the surface. Clamp the electrode to the electrode holder. Turn on the welding machine and pull down the helmet. Hold the electrode by directly pointing away from you and in line with the intended weld. Then, hold the rod at a 45-degree vertical angle with the metal plate. Step number 12. Brush the electrode against the workpiece and then maintain a distance of 3.175 mm between the electrode and the metal plate. With the arc struck and the rod position correct, pull the electrode towards yourself straightly. Maintain the proper angle and the 3.175 mm distance between the rod and the metal plate throughout the entire welding process in order to produce an evenly weld. After the weld is complete, turn off the welding machine. Step number 16. Detach the electrode from the electrode holder and hang the electrode holder back to its initial position. Let the metal to cool down for 1 to 2 minutes. Strike the bit by using the chipping hammer to remove the slack. Then clean the remaining slack from the bit by using the wire brush. Grip the metal plate and dunk it into the water to cool down. Wipe the metal plate until it is clean. And don't forget to examine the metal plate for defects. That is all for the general procedure. Now let's jump deeper into the shielded metal arc welding, starting from the electrode designation. For the electrode designation, the first alphabet E stands for electrode, while the first 2 digits shows the minimum tensile strength. For example, the 2-digit 60 stands for 60,000 psi tensile strength electrode. The third digit indicates which position the electrode can be used when welding. 1 stands for any position, 2 stands for flat position. The fourth digit tells you the current that you can use for the electrode and the coding on the electrode. This is a reference chart for the fourth digit. After knowing the electrode designation, now we need to understand how to choose electrode. There are 5 factors to consider in welding rod selection, and I will explain it one by one. For the first factor, base metal properties, your goal is to match or closely match the electrode composition to the base metal type. Second, tensile strength. You need to match the minimum tensile strength of the electrode to the base metal. Third, welding current. Some electrodes can only be used with DC or AC power source, while other electrodes are compatible with both. To identify this, you can check the 4th digit of the electrode's designation as I just mentioned. Factor number 4 is base metal thickness. Thick material requires electrode with maximum ductility and low hydrogen. In contrast, thin material, you will need an electrode that produces soft arcs, such as electrode with a designation of 6013. The last factor is welding position. To determine what position a particular electrode is qualified for, refer to the 3rd digit of the electrode designation as I just mentioned. There are 2 types of electrode angle. The first one is travel angle, which is an angle between the electrode and the plane perpendicular to the weld axis. It is best to have a travel angle of 15 to 30 degrees from the vertical axis for all positions. The second angle is work angle, which is an angle between the electrode and the workpiece. Different weld positions may have different work angle. For example, butt weld had a work angle of 90 degrees. There are 3 types of electric polarity, which is direct current electrode positive, direct current electrode negative, and alternating current. For DCEP, the electron flows from the workpiece to the electrode, while for DCEN, the electrons flow from the electrode to the workpiece. This result to DCEP will provide a deep penetration, while DCEN will provide a mild penetration. When using the direct current, the welding arc can be affected by the arc flow, which is a deflection of the arc from its normal path due to magnetic force. For this reason, some people would choose alternating current to avoid arc flow. Alternating current will produce a soft arc with medium penetration. There are 2 ways to generate an arc. First, scratch start, where you just scratch the electrode on the base metal like a match. Second, tap start, where you just tap the rod against the base metal. Arc length is a distance between the work material and electrode. The recommended distance is 3.175 mm. If the arc length is too short, the electrode will get stuck to the workpiece or short out. If it's too long, spatter, undercut, porosity can occur. For the do during welding, first, keep dry insulation between your body and the project and the ground. Second, ensure a safe ground connection before beginning. Electric short can cause critical injury or death. Last, inspect all your equipment before each use. For the don't during welding, first, do not operate in an area with combustible material. Second, do not work in close proximity to other welders. Third, do not allow the electrode to come in contact with your skin or clothing to avoid burns. There are 3 defects observed in this weld bead. First, irregular weld shape, which means uneven weld. Second, porosity, which is gas entrapped in weld metal giving a cavity. And third, spatter, which is droplets of weld metal expelled from the weld pool. I will explain each defect starting from an irregular weld shape. The possible causes for this defect is travel speed is too slow, current is too high or too low, and improper arc length. The remedies for this defect is maintain a medium travel speed, set a suitable current, and maintain the arc length at about 3.175 mm. The second defect is porosity, which can be caused by oxide film on parent metal and poorly clean or dirty weld preparation. To solve this, use filler with adequate level of deoxidants and make sure to clean and degrease the workpiece surface. The third defect is spatter, which can be caused by welding current is too high, arc is too long, or incorrect polarity. To overcome this, reduce welding current, reduce arc length, use correct polarity according to the welding condition. Lastly, before leaving the workshop, there are 3 simple things that you need to do. First, make sure your equipment is fully turned off. Second, dispose the waste properly and safely. Third, return the equipment to its original places. That is all from me. Thank you for lending me your ears.